Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in TryHackMe. This is the SOC Level 1 learning path. This is the Digital Forensics and Incident Response module. Windows Forensics 1 Room. Introduction to Windows Registry Forensics. Hopefully you're all ready to learn something today. As usual, before we dive into it, if you are enjoying the content on the channel, you want to help support the channel, be sure to like, comment, subscribe, and hit that notification bell while you're at it. Without further ado, let's go ahead and dive into it. Task 1, Introduction to Windows Forensics. Introduction to Computer Forensics for Windows. Computer forensics is an essential field of cybersecurity that involves gathering evidence of activities performed on computers. It is a part of the wider digital forensics field, which deals with forensic analysis of all types of digital devices, including recovering, examining, and analyzing data found in digital devices. The applications of digital and computer forensics are wide-ranging, from the legal sphere, where it is used to support or refute a hypothesis in a civil or criminal case, to the private sphere, where it helps in internal corporate investigations and incident and intrusion analysis. And that's absolutely correct. In the private sphere, basically, they're talking about if you go and work in a corporate environment and you have an incident that you need to respond to. Let's say that a system had gotten breached, had gotten hacked, and the attackers did all kinds of funky things on there. Well, you would probably need to send that off to a digital forensics team. If you don't have one internally, then you probably use a third-party provider like a incident response retainer. They typically would carry out activities such as this to assist you in your incident response effort. So they will get that image of whatever machine that happened to be compromised, and then they will go and conduct their digital forensics on that particular image, copy of it, what have you, right? So let's go ahead and continue on. A perfect example of digital forensics solving a criminal case is the BTK serial killer case. This case had gone cold for more than a decade when the killer started taunting the police by sending letters. The case took a major turn when he sent a floppy disk to a local news station that was later taken into evidence by the police. The police were able to recover a deleted Word document on the drive, and using the metadata and some other evidence, they pinpointed and arrested him. Microsoft Windows is by large the most used desktop operating system right now. Private users and enterprises prefer it, and it currently holds roughly 80% of the desktop market share. This means that it is important to know how to perform forensics in or on Microsoft Windows for someone interested in digital forensics. In this module, we will learn about the different ways we can gather forensic data from the Windows registry and make conclusions about the activity performed on a Windows system based on this data. Forensic artifacts. When performing forensic analysis, you will often hear the word artifact. Forensic artifacts are essential pieces of information that provide evidence of human activity. For example, during the investigation of a crime scene, fingerprints, a broken button of a shirt or collar, the tools used to perform the crime are all considered forensic artifacts. All of these artifacts are combined to recreate the story of how the crime was committed. So basically, it's who done it, right? In computer forensics, forensic artifacts can be small footprints of activity left on the computer system. On a Windows system, a person's actions can be traced back quite accurately using computer forensics because of the various artifacts a Windows system creates for a given activity. These artifacts often reside in locations normal users won't typically venture to. For our purposes, these artifacts can be analyzed to provide the trial of activity for an investigation. So is my computer spying on me? What do you think? Of course it's spying on you, but we're going to find out. A Windows system keeps track of a lot of activity performed by a user, but is all that tracking for malicious purposes, or is there another reason for that? As we'll see in this room, the file system components that forensic experts deem artifacts primarily originate from Microsoft's efforts to improve the user's experience. Assuming the same build of Windows is installed on a system, excluding the actions taken during installation, the out-of-box experience is similar for all users. However, with time, each user personalizes their computer according to their preferences. These preferences include the desktop layout and icons, the bookmarks in the internet browser, the name of the user, installing of different applications and logging in to different accounts for each of these applications and other accounts using the internet browser. Windows saves these preferences to make your computer more personalized. However, forensic investigators use these preferences as artifacts to identify the activity performed in a system. So while your computer might be spying on you, it is not for the explicit reason of spying. Instead, to make it more pleasant to use the computer according to your taste, but that same information is used by forensic investigators to perform forensic analysis. As we move through this room, we'll see that Windows stores these artifacts in different locations throughout the file system, such as in the registry, a user's profile directory, and application-specific files, etc. In the next task, we'll learn about the Windows registry and how it can help us in the forensic analysis of a Windows system. Note, except for task number 10, which has attached VM, the questions for all upcoming tasks can be answered using the concepts and evidence presented in the text and images. You're gonna have to read, people. I know a lot of people here don't like reading and stuff of that nature, but you're gonna have to read, okay? Just like reading documentation, it's inevitable. But let's get to this question. What is the most used desktop operating system right now? Well, we know that's gonna be Windows. If I could spell, what word do they have for it up here? Let me go find that real quick. Microsoft Windows. Okay. Well, I don't know why they don't put just Windows on there. Everyone knows it's by Microsoft, so you should at least if you're in this room. Task number 2, Windows Registry and Forensics. So let's see what they're cooking with here. Windows Registry is a collection of databases that contains the system's configuration data. This configuration data can be about the hardware, the software, or the user's information. It also includes data about the recently used files, programs used, or devices connected to the system. As you can understand, this data is beneficial for a forensics standpoint. Throughout this room, we will learn ways to read this data to identify the required information about the system. You can view the registry using regedit.exe, a built-in Windows utility to view and edit the registry. We'll explore other tools to learn about the registry in the upcoming tasks. The Windows registry consists of keys and values. When you open the regedit.exe utility to view the registry, the folders you see are registry keys. Registry values are the data stored in these registry keys. A registry hive is a group of keys, subkeys, and values stored in a single file on the disk. Structure of the registry. The registry on any Windows system contains the following 5 root keys. First one is H key current user. Number 2, H key users. We got H key local machine, H key classes root, and H key current config. You can view these keys when you open the regedit.exe utility. To open the registry editor, press the Windows key and the R key simultaneously. It will open a run prompt that looks like this, right? So this is the run prompt. In this prompt, you're going to type regedit.exe, and you will be greeted with the registry editor window. It will look something like this. We can see those in here that we just talked about earlier. Here you can see the root keys in the left pane in a tree view that shows the included registry keys, and the values in the selected key are shown in the right pane. You can right click on the value in the right pane and select properties to view the properties of this value. Here is how Microsoft defines each of these root keys. For more detail and information about the following Windows registry keys, please visit Microsoft's documentation. And then now we have a table here. So we got folder, predefined key, and the description here. So let's take a look here. So we got HKey current user contains the root of the configuration information for the user who is currently logged on. The user's folders, screen colors, and control panel settings are stored here. This information associated with the user's profile. The key is sometimes abbreviated as HKCU. Next one is HK or HKey users. Contains all of the actively loaded user profiles on the computer. HKey current user is a subkey of HKey users. HKey users is sometimes abbreviated as HKU. The next one is HKey local machine. Contains configuration information particular to the computer of or for any user. This key is sometimes abbreviated as HKLM. The next one is HKey classes root. It says it's a subkey of HKey local machine and software. The information that is stored here makes sure that the correct program opens when you open a file by using Windows Explorer. This key is sometimes abbreviated as HKCR. Now, I recommend following along with this. Go ahead and open a registry editor on your machine. Just don't make any changes in there. Just go around and look for for these particular items that we're going over. But anyway, let's get back to it. Starting with Windows 2000, this information is stored under both HK local machine and HKey current user keys. The HKey local machine software classes key contains default settings that can apply to all users in or on the local machine or local computer. The HKey current user software classes key has settings that overwrite the default settings and apply only to the interactive user. The HKey class's root key provides a view of the registry that merges the information from these two sources. HKey class's root also provides this merged view for programs that are designed for earlier versions of Windows to change the settings for the interactive user. Changes must be made under the HKey current user software classes instead of under HKey class's root. To change the default settings, changes must be made under the HKey local machine software classes. If you write keys to a key under HKey class's root, the system stores the information under HKey local machine software classes. If you write values to a key under HKey class's root and the key already exists under HKey current user software classes, the system will store the information there instead of under HKey local machine software classes. HKey current config contains information about the hardware profile that is used by the local computer at system startup. That's a lot to take in. So hopefully you all are taking some notes or rereading through all this again a few times so you can get it in your head. Let's take a look at this question. What is the short form for HKey local machine? So if we go back up here to see what they're talking about here, so we have HKey local machine up here and it's abbreviated as KLM. So we're going to put that in as our answer here. All right, so task number 3, we're going to talk about accessing registry hives offline. If you are accessing a live system, you will be able to access the registry using regedit, and you will be greeted with all of the standard root keys we learned about in the previous task. However, if you only have access to a disk image, which I was talking about earlier, you must know where the registry hives are located on the disk. The majority of these hives are located in the C Windows System 32 config directory and are the following. So we have default mounted on HKey users default, SAM, HKey local machine SAM, security, HKey local machine security, software, HKey local machine software, system, HKey local machine system. Hives containing user information. Apart from these hives, 2 other hives containing user information can be found in the user profile directory. For Windows 7 and above, a user's profile directory is located in C users and then the username where the hives are. So we have number 1 here, ntuser.dat, mounted on HKey user or HKey current user when a user logs in. Number 2 is user_class.dat, mounted on HKey current user software classes. The user class.dat hive is located in the following directory. So you have C users, username, app data, local, Microsoft, and Windows. And here is a screenshot here. All right, so we take note of that. The ntuser.dat hive is located in the directory C users and then the username. There it is down there. Okay, good to know. Remember that ntuser.dat and userclass.dat are hidden files. So if they're hidden files, I know there's a setting inside of Windows. If you're going to be looking through the Explorer, you can select that icon that says view hidden files or show hidden files. The amcache hive, apart from these files, there's another very important hive called the amcache hive. This hive is located in C Windows app compat programs amcache.hve. Windows creates this hive to save information on programs that were recently run on the system, transaction logs, and backups. Some other very vital sources of forensic data are the registry, transaction logs, and backups. The transaction logs can be considered as the journal of the changelog of the registry hive. Windows often uses transaction logs when writing data to registry hives. This means that the transaction logs can often have the largest changes in the registry that haven't made their way to the registry hives themselves. The transaction log for each hive is stored as a .log file in the same directory as the hive itself. It has the same name as the registry hive, but the extension is .log. For example, the transaction log for the SAM hive will be located in the C Windows System 32 config in this file name sam.log. Sometimes there can be multiple transaction logs as well. In that case, they will have .log1, .log2, etc. as their extension. It is prudent to look at the transaction logs as well when performing registry forensics. Registry backups are the opposite of transaction logs. These are the backups of the registry hives located in the C Windows System 32 config directory. These hives are copied to the C Windows System 32 config regback directory every 10 days. It might be an excellent place to look if you suspect that some registry keys might have been deleted, modified recently. Awesome. So let's take a look at these questions. What is the path for the 5 main registry hives? Default, SAM, security, software, and system. All right, so if we scroll back up here, we can see that information what they were talking about earlier in this topic here. So they're going to be located here in the C Windows SM32 config. So it's going to plug that in. What is the path of the Amcache hive? And once again, let's go back up a little bit. So it should be here. So let's see if they need this whole thing. There we go. Awesome. Task number 4, data acquisition. And let's see what they are talking about here. When performing forensics, we will enter or either encounter a live system or an image taken of the system. For the sake of accuracy, it is recommended practice to image the system or make a copy of the required data and perform forensics on it. That's right. You don't want to modify the original in case it goes to like court or something like that, right? So you don't want to get it accidentally thrown out due to evidence tampering or something of that nature, right? Um, very careful when doing this. This process is called data acquisition. Below, we discuss different ways to acquire registry data from a live system or a disk image. Though we can view the registry through the registry editor, the forensically correct method is to acquire a copy of this data and perform analysis on that. However, when we go to copy the registry hives from Windows System 32 config, we cannot because it is a restricted file. So what do we do now? For acquiring these files, we can use one of the following tools. So we have CAPE, which is well known. CAPE is a live data acquisition and analysis tool which can be used to acquire registry data. It is primarily a command line tool, but it also comes with a GUI, which is graphical user interface. The below screenshot shows what CAPE GUI looks like. We have already selected all the settings to extract the registry data using CAPE in the screenshot. We'll learn more about collecting forensic artifacts using CAPE in a dedicated CAPE room. All right, like I said, CAPE is a well-known tool out there. It works great, and I like it because not only does it give you the graphical user interface here, we can play around with it, but down here below you have the command line as well, which we know that the command line is typically more powerful than a GUI when it comes to a lot of these tools. An autopsy. It gives you the option to acquire data from both live systems or from a disk image. After adding your data source, navigate to the location of the files you want to extract, then right-click and select Extract Files options. It will look similar to what we see in the screenshot here. Pretty neat. Autopsy is another well-known one. FTK Imager is another well-known one. It says FTK Imager is similar to Autopsy and allows you to extract files from a disk image or live system by mounting the said disk image or drive in FTK Imager. Below you can see the option to export files as highlighted in the screenshot right there. Good to know there. Another way you can extract registry files from FTK Imager is through the Obtain Protected Files option. This option is only for live systems and is highlighted in the screenshot below. This option allows you to extract all the registry hives to a location of your choosing. However, it will not copy the amcache.hive file, which is often necessary to investigate evidence of programs that have been last executed. And this is what it looks like here. For the purposes of this room, we will not be acquiring data ourselves, but instead we will work with the attached VM that already has data. That saves a lot of time there because sometimes these images can be huge depending on the machine. So if you're doing like a domain controller or something like that, it could be a huge, huge file for the image. So we're done here. Try collecting data on your own system or the attached VM using one of the above mentioned tools. Okay, scratch that. We're going to get to it eventually down here with the hands-on challenge. So we're just going to continue on until we get down to the hands-on challenge. But I recommend going down here and starting up this VM so that you don't waste time waiting for it to start up when you get to that task. Exploring Windows Registry. Once we have extracted the registry hives, we need a tool to view these files as we would in the registry editor. Since the registry editor only works with live systems and can't load exported hives, we can use the following tools. Registry Viewer. As we can see in the screenshot below, Access Data's Registry Viewer has a similar user interface to the Windows Registry Editor. There are a couple of limitations though. It only loads one hive at a time, and it can't take the transaction logs into account. So remember that. Those are the cons of using this particular tool here. All right, but it looks like this. Zimmerman's Registry Explorer. Eric Zimmerman has developed a handful of tools that are very useful for performing digital forensics and instant response. One of them is the Registry Explorer. It looks like the below screenshot. It can hold or load multiple hives simultaneously and add data from transaction logs into the hive to make a more clear hive with more up-to-date data. It also has a handy bookmarks option containing forensically important registry keys, often sought by forensic investigators. Investigators can go straight to the interesting registry keys and values with the bookmarks menu item. We will explore these in more detail in the upcoming tasks. So this is what it looks like here. So this one sounds way more useful than the other one. RegRipper is a utility that takes a registry hive as input and outputs a report that extracts data from some of the forensically important keys and values in that hive. The output report is in a text file and shows all the results in sequential order. RegRipper is available in both the CLI, which is command line interface, and the GUI form, which is shown in the screenshot below. Nice. One shortcoming of RegRipper is that it does not take the transaction logs into account. We must use Registry Explorer to merge transaction logs with the respective registry hives before sending the output to RegRipper for more accurate results. That seems like a very important piece to remember here. Make sure y'all take notes. Even though we have discussed these tools or these different tools for the purposes of this room, we will only be using Registry Explorer and some of the Eric Zimmerman tools. The other tools mentioned here will be covered in separate rooms. Study the above material and understand the difference between the different tools. Now, Eric Zimmerman is well known in this space. These tools are called Easy Tools. So if you go and Google Easy Tools or use your fancy little chatbot AI thing, it'll tell you all about it. Task number 6, system information and system accounts. Now that we have learned how to read registry data, let's find out where to look in the registry to perform our forensic analysis. When we start performing forensic analysis, the first step is to find out about the system information. This task will cover gather information related to a machine's system and account information. OS version, which is operating system version. If we only have if we only have triage data to perform forensics, we can determine the OS version from which this data was pulled through the registry. To find the OS version, we can use the following registry key: software, Microsoft Windows NT current version. This is how Registry Explorer shows the registry key. Take a look and answer question number 1. So this is what it looks like here. Okay, so let's see what question number 1 is real quick. Scroll all the way down here. What is the current build number of the machine whose data is being investigated? So we need to find the current build number. All right, so let's take a look at the screenshot. And let's see, current build number, and it says 19044. So let's go and plug that in as our answer. I already forgot what it was. Let me check again. 19044. Okay, so let's go ahead and continue on reading here. Current control set, the hives containing the machine's configuration data used for controlling system startup are called control sets. Commonly, we will see two control sets, control set 001 and control set 002 in the system hive on a machine. In most cases, but not always, control set 001 will point to the control set that the machine booted with, and control set 002 will be the last known good configuration. Their locations will be system control set 001 and system control 002, respectively. Windows creates a volatile control set when the machine is live, called the current control set, HKLM, system current control set. For getting the most accurate system information, this is the hive that we will refer to. We can find out which control set is being used as the control or the current control set by looking at the following registry value in system select and then current. Similarly, the last known good configuration can be found using the following registry value, system select last known good. This is how it looks like in Registry Explorer. Take a look at answer question number 2. All right, so let's go ahead and see what question number 2 is. Which control set contains the last known good configuration? So last known good configuration. And let's see. It says 1. So that should be our answer there. All right. Next one, what is the computer name of the computer? So that's probably going to be what the next thing is going to be, computer name. It is crucial to establish the computer name while performing forensic analysis to ensure that we are working on the machine we're supposed to be working on. We can find the computer name from the following location: system, current control set, control, computer name, and then computer name. Registry Explorer shows it like this. Take a look and answer question number 3. Okay, so computer name is THM -4N6. So -4N6. Let's go and plug that in. So THM-4N6. What is the value of the time zone key name? All right, time zone information. For accuracy, it is important to establish what time zone the computer is located in. This will help us understand the chronology of the events as they happen. For finding the time zone information, click at the following location: the system, current control set, control, time zone information. Here's how it looks in Registry Explorer. Answer number 4. Okay. Okay, so, and question number 4 was, what is the value of the time zone key name? Time zone key name. All right, so we need to find time zone key name, Pakistan Standard Time. There we go. Pakistan Standard Time. Next one is what is the DHCP IP address? Okay, so let's find that real quick. The time zone information is important because some data in the computer will have their timestamps in UTC, GMT, and others in the local time zone. Knowledge of the local time zone helps in establishing a timeline of merging data from all the sources. Network interfaces and past networks. The following registry key will give us a list of network interfaces on the machine we are investigating: system, current control set, services, TCP/IP, parameters, interfaces. Take a look at the registry key as shown in Registry Explorer. Answer question number 5. So let's take a look here. Use the DHCP IP address. So 192.168.158. 100.58. Okay. 192.168. Today's not my day remembering stuff. I always have to go back and check it again. But let's find it again. 100.58. 58. All right. What is the RID or RID of the guest user account? So let's see here. All right. Each interface is represented with a unique identifier GUID subkey, which contains values relating to the interface's TCP IP configuration, or sorry, TCP IP configuration. This key will provide us with information like IP addresses, DHCP IP addresses, and subnet mask, DNS servers, and more. This information is significant because it helps you make sure that you are performing forensics on the machine that you're supposed to perform it on. The past networks a given machine will or was connected to can be found in the following locations: software, Microsoft Windows NT, current version, network list, signatures unmanaged, and um, signatures managed. All right, so this is what it looks like here. These registry keys contain past networks as well as the last time they were connected. The last right time of the registry key points to the last time these networks were connected. Auto start programs, auto runs. The following registry keys include information about programs or commands that run when a user logs on. Them here. So you got current version run once, another run once, and software, and then we have run and another run here. All right, so let's take a look at the image. The following registry key contains information about the services, so system, current control set, services. Notice the value of the start key in the screenshot. Start key is set to 2. In this registry key, if the start key is set to 0x02, this means that the service will start at boot. Okay, so that is good to know. SAM Hive and user information. The SAM Hive contains user information, or user account information, and login information, and group information. This information is mainly located in the following location: SAM, domain, account, users. Take a look at below screenshot, answer number 6. Okay, what was number 6 again? We need to find the RID of the guest user account. So let's see here. Guest user account, guest. Okay, so 501 or 501 is the guest. So let's go ahead and plug that in real quick so we don't forget. All right, so we're done with that. The information contained here includes the relative identifier, RID, of the user, number of times the user logged in, last login time, last failed login, last password change, password expiry, password policy, password hint, any groups that the user is part of. So very useful there. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Task 7, usage or knowledge of files, folders. Recent files. Windows maintains a list of recently opened files for each user. As we might have seen when using Windows Explorer, it shows us a list of recently used files. This information is stored in the NT user hive and can be found on the following location: ntuser.dat, software, Microsoft Windows, current version, Explorer, and recent docs. So we have an image here of what that looks like here. Recent docs, all kinds of nifty things here. Registry Explorer allows us to sort data contained in registry keys quickly. For example, the Recent Documents tab arranges the most recently used MRU file at the top of the list. Registry Explorer also arranges them so that the most recently used file is shown at the top of the list and the older ones later. Another interesting piece of information in this registry key is that there are different keys with the file extensions, such as .pdf, .jpg, .docx, etc. These keys provide us with information about the last used files of a specific file extension. So if we are looking specifically for the last used PDF files, we can look at the following registry key: nt user data or .dat, software, Microsoft Windows, current version, Explorer, recent docs, .pdf. Registry Explorer also lists the last open time of these files. Answer question number 1 by looking at the above screenshot. So question number 1, when was Easy Tools opened? So when was Easy Tools opened? Easy Tools was opened 2021. 1201 1334. So let's see here. Hopefully you're just needing the date. So 2021 12/1. And it looks like they're needing the entire thing. So okay, I don't know what happened there. My numlock's not working. That's weird. All right, so what was the time again? In 1334. At what time was my computer last interacted with? Okay, that's probably the next one we're gonna get into here. And let's see here. Office recent files. Similar to recent doc, maintained by Windows Explorer, Microsoft Office also maintains a list of recently open documents. This list is also located in the NT user hive. It can be found in the following location: ntuser.dat software Microsoft Office version. The version number for each Microsoft Office release is different. An example registry key will look like this. So we have Office 15.0, then Word. Here, the 15.0 refers to Office 2013. A list of different Office releases and their version numbers can be found on this link there. Starting from Office 365, Microsoft now ties the location to the user's live ID. In such a scenario, the recent files can be found at the following locations. So that's going to be in Microsoft Office version user MRU, live ID, and then the ID number, then file MRU. In such a scenario, the recent files can be found at the following location. This location also saves the complete path of the most recently used files, shell bags. When any user opens a folder, it opens in a specific layout. Users can change this layout according to their preferences. These layouts can be different for different folders. This information about the Windows shell is stored and can be identified by or can identify the most recently used files and folders. Since the setting is different for each user, it is located in the user hives. We can find this information in the following locations, which are these here. Okay, so we have Microsoft Windows shell bags, shell bag MRU, shell bag MRU again, and then bags down there. So make sure to take note of those locations. Registry Explorer doesn't give us much information about shell bags. However, another tool from Eric Zimmerman's tools called Shellbag Explorer shows us the information in an easy to use format. We just have to point to the Hive file we have extracted, and it parses the data and shows us the results. An example is shown below. Take a look and answer question number 2. So let's see what number 2 was again. What time was my computer last interacted with? Last interacted with. Okay, last interacted with, and we have that right here, my computer, and then last interacted. So 1306:47. All right. So 2021, I think it was 27. Okay, it wasn't 27. What was it? 47. All right. So next one here. Open, save, and last visited dialog MRUs. When we open or save a file, a dialog box appears asking us where to save or open that file from. It might be noticed that once we open/save a file at a specific location and Windows remembers that location, this implies that we can find out recently used files. If we get our hands on this information, we can do that by examining the following registry keys, which is this here. So current version Explorer, com DLG32, open save PID 1 MRU or LMRU. Okay, here's the other one here. This is how Registry Explorer shows the registry key. Take a look at question number 3 and 4. All right, so we got Notepad, then there's absolute path, which I think it asked for, then open on. So let's take a look here. Absolute path, Notepad. So C, and what was it? Computer. Okay. So see program files, Amazon. Okay, Amazon, and then EC2 config service. Okay, and the last part was settings. There we go. When was the file opened? 11/30, 10:56, 19. Okay, what was it? 11:30, 10:56, 19. I'll put 11:20 instead of 30. 11:30. There we go. Okay, so we're done with that one. Windows Explorer address search bars. Another way to identify a user's recent activity is by looking at the paths typed in Windows Explorer address bar or searches performed using the following registry keys, respectively. All right, and those keys are here. So we have current version, Explorer, type paths, and then um, word will query. Here is how type paths key looks like in the Registry Explorer. All right, that's good to know there. So we're going to continue on to task number 8, evidence of execution. User Assist. Windows keeps track of applications launched by the user using Windows Explorer for statistical purposes in the User Assist registry keys. These keys contain information about the program's launch, the time of their launch, and the number of times they were executed. However, programs that were run using the command line can't be found in the User Assist keys. The User Assist key is present in the NT user hive mapped to each user's GUID. We can find it in the following location, which is here. So Explorer, User Assist, the GUID, and then count. Take a look at the below screenshot from Registry Explorer and answer question number 1. Okay. So let's see what question 1 is asking. How many times was the File Explorer launched? File Explorer launched. All right. Let's see here. There's File Explorer, and it says 26. So that should be our answer there. All right. Next one up is the shim cache. Is a mechanism used to keep track of application compatibility with OS and tracks all applications launched on the machine. Its main purpose in Windows is to ensure backward compatibility of applications. It is also called Application Compatibility Cache. App Compat Cache is located in the following location in the system hive, which is here. Session Manager, App Compat Cache. Shim Cache stores file name, file size, and the last modified times of the executables. Our go-to tool, the Registry Explorer, doesn't parse shim cache data in a human readable format, so we go to another tool called Compat Cache Parser, also part of Eric Zimmerman's tools. It takes the system hive as input, parses the data, and outputs a CSV that looks like this. So very, very, very useful. We can use the following command to run the app compat cache parser utility, which is this here. So app compat cache parser.exe -csv path to save output -f path to system hive for the data parsing, then -c control set to parse. The output can be viewed using Easy Viewer, another one of Zimmerman's tools. Amcache. The Amcache hive is an artifact related to Shimcache. This performs a similar function to Shimcache and stores the additional data related to program executions. This data includes execution path, installation, execution, and deletion times. Any SHA-1 hashes of the executed programs. This hive is located at the file system at appcompat programs amcache.hve. Information about the last executed programs can be found in the following hive amcache.hve root file, then volume GUID. This is how Registry Explorer parses the amcache hive, so take note of that. Okay, BAM, DAM. Background Activity Monitor, or BAM, keeps a tab on the activity of background applications. Similar, Desktop Activity Monitor, or DAM, is a part of Microsoft Windows that optimizes the power consumption of the device. Both of these are part of the modern standby system in Microsoft Windows. In Windows Registry, the following locations contain information related to BAM and DAM. This location contains information about the last run programs, their full paths, and last execution times. So located here, you got BAM and then DAM. Below, you can see the Registry Explorer parses data from BAM. Okay, so take note of that. Sweet. What is another name for shim cache? Which of the artifacts also saves SHA-1 hashes of the executed programs? And we just went past that, right? That was the, let's see here. So also called the application compatibility cache. So let's go and grab this one. I think this was the first question they had asked. Yeah. Then we need to find the one that does the SHA-1, which we just read about here. Yeah. All right. Just gonna do this the easy way. There we go. Right in front of my face. Amcache. I know I had saw it somewhere. Which of the artifacts saves the full path of the executed programs? So which one saves the full path? Their full paths. Okay, so this is going to be the BAM and DAM. Do we need a full name here? No, we don't. Okay. BAM and DAM. Oop, there we go. Task number 9, external devices, USB device forensics. So let's see what they're cooking with here. When performing forensics on a machine, often the need arises to identify if any USB or removable device or drives were attached to the machine. If so, any information related to those devices is important for a forensic investigator. In this task, we will go through the different ways to find information on the connected devices and the drives on a system using the registry. Device identification. The following locations keep track of USB keys plugged into a system. These locations store the vendor ID, product ID, and version of the USB device plugged in, and can be used to identify unique devices. These locations also store the time and the devices were plugged into the system. So we have a system control set, enum, USB store, and then enum USB. Registry Explorer shows information in a nice, easy to understand way. Take a look at this and answer your questions 1 and 2. Okay, so 1 and 2, let's see if they're asking. What is the serial number of the device from the manufacturer, Kingston? So Kingston serial number. Let's take a look. Kingston, and then we need the serial number, which is this long one here. All right. Well, that's going to be a pain to type in. So let's fast forward. I'm going to fast forward all of these to make it easier to go through. All right, so we have the serial number right there. All right, we have both serial numbers, but we need the Kingston one. So go ahead and grab that, type it in for our answer there. And then question number 2, what is the name of this device? So let's go back up here and we can see the name, device name. There we go. So plug that in. Kingston Data Traveler 2.0 USB device. Is our answer there. Next one is what is the friendly name of the device from the manufacturer Kingston? So we're going to get into that here shortly. First and last times. Similarly, the following registry key tracks the first time the device was connected, the last time it was connected, and the last time the device was removed from the system. And it's located here. So take note of that. In this key, the pound or number sign can be replaced by the following digits to get the required information. So you have the value, then information there. First connection time, last connection time, and last removal time. Although we can check this value manually, as we have seen before, seen above, the Registry Explorer already parses this data and shows us if we select the USB store key, USB device volume name, the device name of the connected drive can be found in the following location, Windows portable devices and devices. It looks like this here. Okay, there's a friendly name, which I think is the next question. We can compare the GUID we see here in the registry key and compare it with the disk ID we see on the keys mentioned in the device identification to correlate the names with unique devices. Take a look at these two screenshots and answer question number 3. Combining all this information, we can create a fair picture of any USB devices that were connected to the machine we're investigating. So once again, what's the friendly name of the device from the manufacturer Kingston? That's going to be USB, as we can see up here. So we're done with that task. Now we're going to get some hands-on stuff here with 10. We got a challenge. So now that we have learned something, let's put it into practice. Launch the VM. A Windows VM should show up in the right after your browser window. Please allow a few minutes for the machine to boot. If you don't see a desktop, click the show split screen. The setup is preferred, or if preferred, use the following credentials to log into the machine. Okay. Once we log in, we will see two folders on the desktop named Triage and Easy Tools. The triage folder contains a triage collection collected through CAPE, which has the same directory structure as the parent. This is where our artifacts will be located. The Easy Tools folder contains Eric Zimmerman's tools, which we will be using to perform our analysis. You'll also find Registry Explorer, Easy Viewer, and apt cache parser.exe in the same folder. Note, although the autopsy tool on the desktop can be used to solve this issue, it is recommended that you use the easy tools as demonstrated in this room. So the challenge, and so we need to use easy tools, not autopsy. Okay. The challenge, now that we know where the required tool set is, we can start an investigation. We'll have to use our knowledge to identify where the different files for the relevant registry hives are located and load them into the tools of our choice. Let's answer the questions below using our knowledge of the registry artifacts. Scenario: one of the desktops in the research lab of organization X is suspected to have been accessed by someone unauthorized. Although they generally have only one user count per desktop, there are multiple user counts observed on the system. It is also suspected that the system was connected to some network drive and a USB device was connected to the system. The triage data from the system was collected and replaced on the attached VM. Can you help Organization X with finding answers to the below questions? Note, when loading registry hives in Registry Explorer, it will caution us that the hives are dirty. This is nothing to be afraid of. We just need to remember the little lesson about transaction logs and point Registry Explorer to the .log1 and .log2 files with the same file name as the registry hive. It will automatically integrate the transaction logs and create a clean hive. Once we tell Registry Explorer where to save the clean hive, we can use that for our analysis, and we won't need to load the dirty hives anymore. The Registry Explorer will guide you through this process. So we got some questions here, and y'all already know what to do. Go ahead and pause the video, try to answer the questions yourself, then come back to the video, and we will step through it together. So have fun. Okay, for these first few questions, we're going to be looking at Easy Tools folder, Registry Explorer, fire Registry Explorer, load hive, and we're going to look at the SAM hive. Okay, so how many user created accounts are present on the system? Flip over to the VM, fire up Registry Explorer, which I already have running. As you can see there, so file, load hive, and we are in the C Windows System 32 config. Okay, so we need to load up this SAM, see if it doesn't give us any issues here. Awesome. And we need to take a look here. Let me just make this a little bit bigger. Okay, so let's go ahead and hit this drop down here. All right. Users. Okay, it looks funky. And let's see if we can make it bigger. There we go. This is what I was looking for here. Make it full screen, and then see if we double click in here. Let's do this. There we go. All right, so this looks a little bit cleaner, but let's go ahead and drag this over. All right, so we need to, how many user counts are present on the system? Yeah, how many created accounts are present in the system? Okay, so we see that these are going to be the default ones: administrator, guest, default account, this WDAG utility or whatever. The ones that are created are going to be these here. So we have user 2, user, and this last one. So we got 3 listed there. So we'll plug in 3 as our answer for that. What is the username of the account that has never logged in? So let's take a look here. And it's got to be one of these last password change, incorrect password, last log on time. So let's check that. It never logged in, so this is blank. So it should be this one, this user here. So I'm going to Control C and see if we can just copy and paste this over. Okay. Well, I guess they didn't like that. So THM user 2. All right. What's the password hint for the user THM496? So THM496, and we need to find that password hint, which is probably going to be this field here. Password hint, and it says count. So count. Okay. Now let's go ahead and grab these next answers here. All right, next one is when was the file changelog.txt accessed? So flip back over to our VM. Now this one is going to be located in the C users THM 496 desktop triage C users THM dash 49 4N6, sorry, because that's the active user on the machine, right? So let's go ahead and check that here. 496, and then we need to load up this into user.dat to get that information there. All right, for this one, let's talk about dirty hive detected. You want to replay transaction logs against this hive? Sure. Okay. When in doubt, select them all. Let's just do this first one, I guess. Let's see. Okay, that's good to know there. This is the clean one, so let's just throw this into triage, C, and I forgot where this was. Okay, yeah, users. This user here, and we'll just save it in here. Do you want to load the updated hive? Yes. Do you want to load the dirty hive? No. Okay, so let's take a look at this one here, and you want to expand this. Let's check this question again. When was the file changelog.txt accessed? So we need to find that. And if I check my notes here, we can find that in the recent docs. So we need to go to software, Microsoft Windows, current version, Explorer, recent docs. So software, current, software, Microsoft Windows. All right, Windows. I think it was, current version, Explorer. And I just scrolled past it. All right, now we need to find recent docs right there. Sweet. Right off the bat, we can see it here, changelog.txt, and here's the opened on. So let's go ahead and Control C, see if we can grab it out of here. There we go. So it should be the same date. If you want to double check it, plug that in. But that's the date we needed there. The next one is what is the complete path from where the Python 3.8.2 installer was run. So once again, I'm gonna check my notes here, and we're gonna look at the user assist area. Let's flip back over here. So let's take a look here, and let's see if I can minimize this. So user assist, software Microsoft Windows, current version, Explorer, user assist. All right, I had to manually navigate to it, but it's in the same area. So software, Microsoft Windows, current version, Explorer, user assist, and it's going to be this GUI there, and then count. So we see that here, the GUI, and then we see the count. And we needed to grab, let's see here, it was what is the complete path from where the Python installer was run. So there's this little nifty find thing here. So let's just type in Python, enter. There we go. So we have Z setups Python 3.8.2.exe. So that should be our answer there. And next one is, when was the USB device with the friendly name USB last connected? So let's take a look here. So when you go to software, Microsoft Windows, portable devices, and then devices. So let's go ahead and back out a little bit. All right, for this one, we need to go to C Windows System32 config, load up this system here. Okay, yes, okay, and then we'll do this first one here. All right, we'll do the same thing. We'll just save it to the triage folder, whatever. We'll just save it here. Okay, so we're done with that. Dirty Hive, no, I don't want to load it. So once this is done loading up, now we can go and sift through here, and we need to go to this system control sets, enum, USB store. Okay, so we need to find this information here. All right, now we didn't see that initial friendly name, but what you have to do is, in order to find this friendly name, you have to go and load up the software hive, okay? So the software, and then go to Microsoft Windows Portable Devices, and then Devices, which I'm in right now. You can see this down here at the bottom. And you got to take note of this GUID. So once you have taken note of that, you have to go back and use that information in the system hive that we were just in before. Now go down to the system hive, and then you go to enum, right? And then inside enum is that USB store. So click on that, and that's where you will use that GUID information in order to find that the one in question here, which should be this one here, this Kingston one. And then just grab this last connected time. So that was not as straightforward as I thought it would be, but that's how you can get to that particular answer. Just grab that, plug it in as our answer, which is odd because it says um, when was the USB device with the friendly name USB last connected. And if you take a look here, I mean, I don't see that in here for the friendly name, unless it's in a different location. But that's the one I grabbed out of here and plugged it in as the answer. Okay, so we are done with that. If you want to double check here, but let's click this hint and see what it says here. They have this new AI stuff here. I was playing around with it earlier, but hey, this is the hint you're looking for. Is that it? Okay, whatever. But anyway, so we found the answer for that one, and now we're done. Task number 11, conclusion. Phew, wasn't that interesting? We have learned how to gather basic information about a computer and its users, identify which files they used, which programs they ran, and any external devices connected to the system. If it was a little harder for you to keep track of all the artifacts, download this cheat sheet on this task. So you can check out this cheat sheet and very useful information. I wish I had included this earlier on. This would have been very helpful. But sometimes you have to fumble around and stumble through some things. We got through it together. You can use the links provided within Task 3 to explore more about the tools we introduced. Furthermore, if you like, you can play around with Cape, Regripper, and easy tools in the VM and the task room, so feel free to do that. You can learn more about Windows Forensics in our Windows Forensics 2 room, where we cover even more exciting ways to perform forensics on a Windows machine, in the Cape room to understand how to perform forensics in a quick and efficient manner. Review the provided resources. All right, we are done. So hopefully you made it through all the way to the video. Hopefully you had fun. Hopefully you learned something. And if you enjoyed the content, be sure to like, comment, subscribe, hit that notification bell if you want to help support the channel. As always, thank you for taking the time to watch my video. Have a nice day, and I will see you later.